We're so accustomed to the blue of the sky and the clouds, to dense fogs that prevent us from seeing the sun, to water in the form of rain or snow, to winds of any intensity, that we do not wonder where in the atmosphere these phenomena occur that take place above our heads. Not even that above them is outer space. We invite you to join us on a journey that will take us from the Biblioteca Nacional de España through the different layers of the atmosphere to outer space. From Earth to Moon, a journey through the Earth's atmosphere. Knowledge of the atmosphere in the 19th century was very limited, and it was not until the late 20th century and early 20th century that scientists and meteorologists had the first tools and means to elevate instruments to great heights, and thus be able to study the phenomena that occurred there. The Earth's atmosphere has 5 layers: the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. The first layer we'll go through is the troposphere. It is the thinnest, about 20 kilometers maximum thickness, ranging from 7 kilometers in the poles and 20 kilometers in the tropics. This layer is where we live, and the one that allows life on Earth by its composition, with 21% oxygen and 78% nitrogen, followed by argon, carbon dioxide, and water vapor. The troposphere acts as a thermal regulator of the planet, and it produces most atmospheric phenomena, such as clouds, winds, or snow, due to variations in temperature and air density mainly. It is in the troposphere where jet planes make their air routes. From 2,000 meters, the temperature drops 6.5 degrees for each kilometer of altitude until it reaches the tropopause, the border that separates the troposphere from the next layer, the stratosphere. It starts at a variable height and extends up to approximately 50 kilometers in height. In the stratosphere, unlike the troposphere, or what happens in the upper layers, the temperature rises due to ozone molecules that absorb electromagnetic radiation. Only a few planes like Concorde or the MiG-31 can fly at this level. In the stratosphere, we'll find the ozone layer, which is responsible for absorbing the ultraviolet rays of the sun, acting as a protective layer of life on Earth. At the end of the stratosphere is the stratopause, where the high concentrations of ozone end and the temperature stabilizes at 0 degrees, giving way to the mesosphere. In the Hispanic Digital Library, we can find extensive documentation on trips to the stratosphere. Among them, we highlight those of the physicist Picard, whose objective was to unveil the mystery of cosmic rays and measure their intensity. On May 27, 1931, it reached 16 kilometers altitude using, for the first time in history, a pressurized aircraft equipped with a helium balloon. Picard, Hergé's friend, served as inspiration for the creation of his character, Professor Tournesol, who accompanied Tintin in his adventures. The mesosphere extends from 50 to 80 kilometers high. It happens as in the troposphere, and as we ascend, that the temperature decreases. This layer is responsible for stopping meteorites when they fall into the atmosphere, where they burn, leaving traces of fire in the night sky. It's what we know as shooting stars. Through the mesopause, we arrive at the thermosphere, also called ionosphere, which can reach up to 500 or 100 kilometers of the Earth's surface. It's called thermosphere because of the high temperatures that are reached since the gases are ionized. Since it's a conductive layer of electricity, it makes radio and television transmissions possible due to its property of reflecting electromagnetic waves. In our trip, we can probably enjoy one of the most spectacular phenomena that can be observed from the Earth, the auroras borealis, or australis, and that occur when the particles of gas in this layer are charged with energy from the sun. Also, this is the layer where the space shuttles operate, and if we are attentive, perhaps we can see the International Space Station pass, which has a stable orbit between 320 and 380 kilometers high here. If we go through the thermopause, we'll reach the exosphere, the last atmospheric layer where gases disperse little by little until they become confused with outer space, where there is practically a vacuum. In this layer we find a high content of cosmic dust that falls on the Earth and is the ideal layer for orbiting artificial satellites, as there is very little friction. Once we reach outer space, we'll be able to see in detail our companion satellite, the Moon, which always shows us the same face, with its mountains and craters as a consequence of the impact of meteorites on its surface. Today, its orography is known in detail, but it's not always been so. At the beginning of the 17th century, Thomas Harriot and Galileo Galilei made the first lunar maps. where they showed with great surprise that it was not the perfect sphere that was believed, but that its surface was full of irregularities in the shapes of mountains and craters. But it was with the invention of photography at the beginning of the 19th century that the first snapshots of the lunar surface could be taken, which allowed all those who did not have a telescope within reach to see the details of our satellite. We end our journey with the vision of the Earth, our home. We hope you enjoyed it and that you will join us in future trips.